You guys know why it's called a pizza? Yeah, because pizza. So we have our area of a square is pi r squared. And pi we also write as pi, okay? So we have pi times the r squared. Let me call our radius z, so we have z squared. And we know anything squared is just z times z. So we have p z z, and then we have this sort of length, or I don't know, like height of this. Let's call it a, and we're gonna multiply that by a to get the entire sort of volume of our pizza. So we multiply that by a, and we have pizza. Formula for the pizza. All right. Anyway, not the point of the video, but I just thought it was kind of funny. Okay, so what is a radius or a radian? I mean, we know what a radius is, right? It's sort of this little distance here coming from the center, extends to the edge of the circle. But what is a radian, right? We know we use 2 pi radians for the entire circle. We use pi radians for the half of the circle. But what exactly is a radian? Well, from the name, we can sort of know that it has to do something with radius. I mean, it sort of sounds the same. Radian, radius, kind of sounds similar. You'd be right, because let me actually show you something. So let's pretend this is our unit circle. This just means this has a radius of 1, a circumference of 2 pi. So let me actually do something here. Let me pretend this radius is this piece of string. And I'm going to wrap this piece of string around our circle. And let's see how many of these pieces of string I can wrap around our circle. So what I mean by this is, let me start here, okay? So let me sort of wrap this around our circle. We would probably get like this far. I think that's fair. Okay, let me darken this just to make this a little more obvious. So we wrapped around our radius once over the circle, and if you've gotten this far, this is what we call 1 radian. This is how far we would get if we wrap the radius of the circle sort of around the edge of the circle, right? Now, what if we want to go even further and we use our radius as our measuring reference, right? This is now 2 radian. And if we keep going more, now we have 3 radians. Okay, but if you notice here, I sort of try to draw it here in a way that you guys can see. We're missing this tiny piece here. We're conveniently missing this tiny piece here. We haven't fully wrapped around half of the circle, but we're pretty damn close. And this piece that actually turns out is 0.14159. And if we now add these, we get 3.14159 radians to get to wrap sort of our radius around the half of the circle. This is a magic number that I'm gonna represent, right? I'm gonna borrow from the Greeks. I'm just gonna steal one of their alphabets. I don't know why, but this is inconvenient to remember, so I'm just gonna call this, I don't know, the Greek letter pi. So now we have pi radians, right? So that is what a radian is, and this is why we say the half circle is pi radians. And I'll give you 3 seconds to guess what the entirety of the circle is. Well, it's just 2 pi radians. Actually, I should have said I gave you 3.14159 seconds, but so they messed that up. Anyway, that is what a radian is. This is why we have 2 pi radians for the entirety of the circle. Actually, this is also why your circumference formula is 2 pi r. If we have a radius of 1, this r, we don't need to include it, it's just 2 pi. But since we know a sort of the size of the circle is inherent, it depends on the radius, then we add this radius on to actually get the entire circumference, right?